Okay, in this video, we're going to look at how we can come up with some parametric equations that will, when you put in values for t, produce a particular curve. And we're just going to first look at a pretty simple example here and see how it works. So what we want to do is find a pair of parametric equations for a line that passes through the points A and B, where A is at 2, 4, B is at 4, 10. So what we can do first is we can get the equation, the Cartesian equation of what that line would be. And you just do that in the usual way. So first I would find the gradient where it's just y2 minus y1, x2 minus x1. So we got 4 take 10, and we have 2 take 4. So what that would be on the top, -6, and on the bottom, -2. So we get 3. And then we need to get the full equation right. So we need to get the C value. I'm going to use that fast equation where you just put in the points. It's y minus y1, so I'll just use the point A. And then we've got m, so that's 3 times in brackets x minus x1. So if I used 4, I've got to use 2 now. And just expand the brackets and rearrange for y. So we get 3x take 6. And we'll have to add on 4 to that to get y by itself. And you get, what do you get? 3x take 2. Now, so we found the Cartesian equation just as you would the normal way. In order to parameterize it, it's actually really easy. All you could do, one way to make a set of parametric equations that would produce this curve is just say, well, I'm going to just let x be t, and then y could be 3t minus 2, and pretty quickly you could probably see that that set of parametric equations would be would make that Cartesian equation, right, of a line that goes through those points. And here is some more working. Now, so that's pretty easy, isn't it? Now, if you think about it, had I used x is 2t and y is equal to 6t minus 2, well, when I do the substitution, I will still get 3x take 2, right? So it's the same line. And you could do that with lots of different values for your putting in your parameter. So funnily enough, there's infinitely many ways to parameterize, to make a set of parametric equations that will produce the Cartesian equation, the Cartesian curve of that, which is pretty handy. And maybe you can think of a couple ones yourself. All right, let's leave it there.